Hello everyone, welcome to my favorite topic in the entire syllabus, integration. Now first, what integration is it's the opposite of differentiation. Okay, we know how to differentiate, let's say something like ax with respect to x. So differentiating ax with respect to x will yield us a. Now, integration is just the opposite. If we integrate a with respect to x, we will get ax. This over here on the left, this squiggly line is your integration symbol. And this dx just tells you that you're integrating with respect to x. Now one more thing for integration is that you always have a plus c in your answer. Why is this so? Because if we differentiate ax plus c, where c is just any constant, we'll actually just get a. Because differentiating a constant will just give us 0. Now let's get familiar with the power rule. Integrating x to the power of n will get us x to the power of n plus 1 over n plus 1. And don't forget your plus c. Now this works for any real value of n. So let's say n equals to half, n equals to 3 over 2, n equals to negative 5. But this does not work for n equals to negative 1, which basically means 1 over x. Again, this rule is just the opposite of differentiation. If you differentiate the right side, you will get x to the power of n. Now, if you have a multiplicative constant, let's say you have the integral of k times fx, this is the same as k times the integral of fx. And also, if you have the integral of fx plus gx, this just equals to the integral of fx plus the integral of gx separately. Now, what I want you to know is the reverse chain rule. So usually with chain rule, what you want to do is replace x over here with fx, and then you times by f prime x on the right side over here. However, for integration, we can't replace x with any fx. It can only be a linear factor, ax plus b. So let's say we want to integrate ax plus b to the power of n. We'll replace the x over here with ax plus b, as you can see over here. And then you need to do one more thing, divide by a. This is what we call the reverse chain rule. And look at this, it only works for linear factors. So something like x squared plus 1 to the power of negative 5 doesn't work. As in that, we cannot use this to help us to integrate. Now, let's look at this first question. Now, this question is very important because it reminds us that sometimes we don't need to use difficult integration techniques to help us integrate. In future videos, we'll be learning some of these integration techniques, such as integration by substitution and integration by parts, but sometimes algebraic manipulation is enough. So if we do the expansion at the top, we'll get x squared plus 2x plus 1 over the square root of x. And then we have a dx. Now let me express everything in terms of powers of x. So I'm just going to divide everything by square root of x, and I should get something like this. And finally, we'll just do our integration. So let's integrate this part first. We have x to the power of 5 over 2. And then over 5 over 2. And this is just 2/5 x to the power of 5 over 2. And if we continue doing this, we should get plus 4/3 x to the power of 3 over 2 plus 2 x to the power of half plus c. Don't forget the plus c, guys. Now the next question I want you to look at is the integral of cosine squared 2x with respect to x. So we know that the derivative of sine x is just cosine x. So in the same vein, the integral of cosine x is just equals to sine x, again with the plus c. So how are we going to solve this? We don't know how to integrate cosine squared 2x. There's no rule for that. Now what I want you to do is use the double angle identity for cosine. This is your original cosine 2x formula, but let's say I make it cosine 4x. I can see a cosine squared 2x there. That means that cosine squared 2x is actually just half cosine 4x plus half. So my integral is actually just half cosine 4x plus half. Now remember, if you want to apply reverse chain rule, we want to integrate cosine ax plus b, this will be equals to sine ax plus b, and remember to divide by a. Now if you have integral of cosine 4x, this will just be sine 4x, and remember to divide by 4. So what we'll get is that this is 1 over 8 sine 4x plus half x, and remember your plus c. Let's do the next question. Before we start, let's go through the integration formula we're going to use. So remember, d over dx of ln x will be equals to 1 over x. So if you want to integrate 1 over x, you get ln x. But take note, this is actually ln mod x. This has to be a modular sign over here when we're doing our integration. Now, if you look at this integral over here, it's not immediately clear what we need to do, but if you look at this is kind of in the form of partial fractions. This is what we get after long division. Now we want to do the partial fractions on this. Now this is what we get after we do the partial fractions from here. Now if we do our integration, this should get x squared over 2 plus 2x. And for these two, remember if you want to use reverse chain rule, since this is a linear factor, we replace this with 1 over ax plus b. This becomes ax plus b. And then remember to divide by a. So with reverse chain rule, this is what the integral should look like. So this will be ln 4x plus 4, remember the modular sign, and then we have a 1/4 outside. Over here, we have 27 times ln 4x minus 12, and remember using reverse chain rule, we need to divide by 4. Now the last part will be revolving around integrals involving inverse trig. These two are directly in your formula booklet. So let's go through this. If you have the integral of 1 over the square root of a squared minus x squared, this will be equals to arcsine x over a plus c. And similarly, if you have the integral of 1 over a squared plus x squared, this is equals to 1 over a arctangent x over a, and don't forget your plus c. Now for this question, find the integral of 1 over 25x squared minus 10x plus 10. It may not be very clear what you need to do first. The trick is you need to complete the square. If you do completing the square, this should look something like this. And this over here matches the form over here. Just that this x has been replaced by a linear factor. So what we're doing when we're doing reverse chain rule is we have 1 over a squared plus, let's say, px plus q square, and then dx. This will be 1 over a, and remember you have to divide by p because we're replacing it with px plus q, and then you have arctangent of px plus q over a plus c. So over here, what we get is 1/3, because that's your 1 over a squared is 9, so a is just 3. And then by the reverse chain rule, since we have 5 here, we need to divide by 5. And then we have arctangent of 5x minus 1 over a, again, a is 3, plus c. Here's the summary sheet for all the basic integration techniques. So first of all, when we want to use reverse chain rule, we are replacing all the x's over here with ax plus b. And remember, this can only be a linear factor. It cannot be something like x squared plus 1. And then after that, then we divide by a. For some questions, algebraic manipulation may suffice. And for questions such as these and these, you may have to use trig identities or partial fractions. Now when it comes to inverse trig, it is important to realize when we can use inverse trig. Sometimes this may be hidden behind a completing the square. Thank you so much for watching. I hope you've learned a lot from this video.